Good day to everybody. This is data structures, and in today's class, we discuss about the classification of data structures, about the arrays, about the iterations, and of course the invariants. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. Right. So in this class, we'll try to classify data structures. What are the primitive data structures and non-primitive data structures? What are arrays, stacks, queues, graphs, and trees? Okay. And what are the most commonly used operations with data structures? What are the iterations that are available? What are the invariants especially available in data structures? And what are the loop invariants? Okay. So I've already given the invariant work in the MS for you. Please complete them as soon as possible. And at regular intervals, I'll be giving you some short videos or animations for your knowledge. Okay, right. So this is classification of data structures. Normally, we will classify into two types: primitive data structure and non-primitive data structure. Okay, right. So in the primitive, we'll have like integer, float, character, pointer. Okay. In non-primitive data structures, we'll have arrays, lists, and files. So in list also we have two types: linear list, non-linear list. In the linear list we have stack and queue. Non-linear list, it's nothing but graphs and trees. Okay, right. So this is actually the classification of data structures. So whenever you say data structures like primitive data structures, it's nothing but basic structures where you can operate by the machine instructions. Okay, so you have to represent it, this one, using maybe integers or maybe floating point data types, character constants, string constants, pointers, and so on. Okay, for example, we'll have like float, integer, character, and then pointer. Okay, so float is nothing but a term that's used in programming language where you try to define the variable with a fractional value. Okay, like for example, 5.6. So that's actually some value. Okay, like decimal value. Okay, suppose even that 5.6 can be represented as a fraction also. Okay, like 6 by 5. 6 by 5 is actually 1.2. So that's how we'll have one fractional value. Okay, so it's contrast of the integer data type. Okay, therefore the numbers created using float, okay, will have decimal point. Okay, so which means that you have to have both sides of decimal point. Okay, like 25.25. So if you have to represent, so you need float. Okay, so we can say that programmers will be using this float term before the name of the variable. Okay, so you have to declare the value for the float variable by using the name of the variables, and after that you have to add the equal to sign. Okay, and you have to have a value. Okay, for example, x is equal to 0.25. Okay, so that is how it goes. Then you have integer. Okay, it's nothing but a whole number, not a fractional value. Okay, so the integer can be positive or maybe negative or maybe zero number. Okay, so maybe like plus 10, plus 11, plus 0. So 0 has both positive and negative. Okay, maybe minus 7, minus 67. Okay, 5148, they are considered to be integers. Okay, but only thing, integer will not have dot. The decimal value it does not have. Okay, so when two integers are added or maybe subtracted, multiplied, divided, the result is always an integer. Okay, so then you'll have character, which we represented using symbols, maybe like capital A, small b, small f, capital R. Okay, dot, white spaces. Okay, so that's how you can represent character and symbols as well. Okay, so here you can store the basic character set even, and it can hold only one letter or maybe symbol, maybe like n or maybe f or maybe d, capital, small, you can have of different data types. Okay, then you have pointer. Okay, it's nothing but the storage location in the memory, random access memory. So in random access memory we'll have like cells or maybe values that is stored in the cells. Okay, so every cell in the memory is 1 byte and the memory address is always a unsigned integer. Okay, so which means that every cell has a unique address pointing to it, this one. Okay, Then you have non-primitive data structures. Okay, it's like you define it in your own data type. Okay, so this one non-primitive, I define in my own way, you define in your own way. This is non-primitive data structures. Okay, it's a more sophisticated data structure as well, and of course it's derived from the primary or maybe primitive data structure. Okay. So non-primitive data structures emphasize on structuring of a group, what you call to be homogeneous or maybe heterogeneous data items. Okay. So arrays, lists, files are considered to be examples of the non-primitive data structures. Okay. So whenever you say like efficient data structure, it is all about operations that are performed on the data structure that's actually taken into account. Okay. For example, let us consider a data structure will be having like different data items. So here the data structure you are going to manipulate it with like different major program functions. So finally you are going to evaluate this operations. Okay, so that's how you define the abstract data type. Okay, so these are the examples: arrays, lists, files, stacks, queues, graphs, and then trees. So these are the examples. Okay. So we continue. Okay, an array. Okay, it's nothing but the collection of items specially stored in some contiguous memory locations. So which means like arrays are nothing but a set of homogeneous data elements which is actually stored in the random access memory. So which means it can hold only one data type. Okay. So data should be like floating numbers or maybe characters or maybe integer numbers. Okay, for example, using arrays, it's much more easier to calculate. Okay, what is the position of each element that you can add a offset to the base value. Okay, so here you will have like single subscripted values, what you call to be linear array or maybe 1D array, and maybe two subscripted variables, what you call to be two-dimensional array, 2D array. Okay. So maybe you will have this one, maybe Z, U, R, H, L, Y, A. Each of them will be having like locations 101, 102, 103, 104, 107 up to it will go on. Okay. So each of them will be having from the arrays 1, 2, 3, 4, 5, 6, 7 and so on. Okay. So this is the subscript I'm talking about. Like we will have the array name 2.1, 4.2, 7.2, 3.3 and so on. Okay, so this is X. Okay, the subscript it is 1, 2, 3, 4, 5, 6, 7. Okay, so this is a one dimensional array. Now here you will have two dimensional array, row, column. Okay, so this is the row subscript. It will start from 0, 1, 2, 3 and column it will have 0, 1, 2, 3. Okay, so here it will be having 5, 14, 6, 1, 8, 2. It can have like positive values or maybe negative values, but only thing it will be in the form of the rows and then columns. Okay. So next you will have list. Okay, it's nothing but a collection of variable number of data items. So maybe list or maybe sequence, you can call it to be ADT, abstract data type, which is going to represent a countable number of the ordered values. So every list element will be having at least two fields. One field maybe for storing the data and another field for storing that particular address of the next element. Okay, so we can see or that the lists are examples of containers because it is going to contain the values. Okay, and if the same value occurs several times, then each occurrence you can call it as a distinct item. Okay, so here from the head it will go to student, teacher, principal, manager. Okay, so from the teacher you will have like information field and this one you can call it as the pointer field. Okay, so this is the linear linked list. Okay, head, student, teacher, principal, manager. So this is how it goes. Then you'll have files. File means it is going to contain some information. Okay, so this information is going to store permanently, maybe in the hard disk and floppy disk, and the disk it's also known as the secondary storage device. So you can store a little byte of data and maybe large amount of data in the secondary devices. Okay, so the file name will be having both the primary name and secondary name and one dot. So that dot is going to separate. So that's how you are going to better understand the concepts. Okay, so for example, welcome.txt, this is the extension. Okay, so this is the primary name, welcome. Okay, dot is nothing but the separator, txt is nothing but the extension or maybe the secondary name. Okay, and the whole thing you can call it as a file name. Okay. Then you have stack. So it's a basic data structure where you are going to have an ordered collection of elements where you are going to represent it by the physical stack or maybe pile. Okay, so maybe you'll have linear data structure that you'll have insertion and maybe deletion of items that can happen in the top of the stack. Okay, so in the structures like a data set, okay, it's considered as the maybe like a stack of books or maybe a stack of plates, okay, one after the other in the stack, and maybe you can remove in the item in the top order. Okay, from there are plates means you cannot remove from bottom immediately, everything will broke down. So from the top you are going to take into. Okay, so maybe these concepts you are going to utilize them in the programming of data structures. Okay, so in the implementation, okay, of the stack, you can call it as a last in first out. For example, you put the plate first, second, third, fourth, last only you will take, that is last in first out. Okay, so there are concepts in the performance on the stack segment. Push, you're going to insert the items into the stack. Pop, you're going to remove or maybe delete an item from the stack. Pip, you're going to display the content of the stack. Okay, next you have queues. Okay, so queue, it's nothing but FIFO, first in first out. Okay, so queues are also part of non-primitive linear data structures. So in the queue process, we can insert an element in a queue from the rear end and maybe delete from the front end only. Okay, so maybe if you have like an array, okay, like 7, 49, 79, 21, 5, 2, rear is towards the end and front is towards the first. Okay, so an element, okay, can be inserted from the rear end and can be deleted from the front end. Okay. So the graphs will have like connected graph, non-connected graph, directed graph, non-directed graph as well. Okay, so here the graphs you can consider as the linear type, like non-linear, okay, and non-primitive type of the data structure even. So normally graph you can call it as non-linear and non-primitive only. Okay, so the graphs maybe you can represent maybe even in the real time like physics or maybe mathematics or maybe chemistry or maybe engineering graphics or so on. You can use these design data structures. So this is a connected graph from A till B, okay, B to A to C, C to D, D to E, C to E. So everything is being connected and everything will be having arrows from here to here or from here to here. Then you have trees, okay, so it's non-primitive and non-linear category of data structure. Okay, using tree you can establish a hierarchical relationship. For example, from your grandfather, your father. From your father, you. From you, your children. From your children, grandchildren. So that is how it goes. Okay. Root A, B, C. B will have D, E, F. C will have G, H, and I. Okay. And C is nothing but the child of this parent. And I is nothing but the child of this root. Okay. So that is how it goes. Okay. So here we'll be having create operation, delete operation, selection operation and update operation. Okay. So in the create operation, you'll be reserving the memory for the program elements. Generally, it can be done by the declaration statement. Okay. So the creation of data structure can happen, okay, during compile time or maybe during the execution or maybe runtime. Okay. So delete operation, that's going to destroy the memory space allocated for the specified data structure. So here you will be having malloc and then free. Okay. So here the C language is used for generally two operations. Okay. Then you have selection operation that you are going to access the particular data within the data structure. So then you will have update as well. So update is going to modify, is going to edit the data in the data structure. Okay. So classification of this data structure is how is all about how you try to add new data structure or maybe that's going to replace with the previously stored data. Okay, so that you can store it, that previously stored data will be deleted and new data will be replaced and subsequently the operations will perform. Okay. Then you have searching, sorting and merging. Okay, so searching, generally you are going to search for the desired data item in the particular list of the data item. So then you'll have like sorting, of course sorting, ascending or maybe descending. Okay, so you can order the particular values as well. and finally merging, you're going to combine the data, okay, of maybe two different sorted lists into a single sorted list. Okay, either it will be like 5 types is there, this one you sort, this one you sort, this one sort, and combine everything. Okay, so maybe if you have like larger number of items in a list means, so you can divide and sort. Okay, and you can combine. Okay, so this is array in the data structure. You can store more than one data item that is having a similar data type. This is very important, that is having a similar data type. So here the items are allocated at adjacent memory locations, and this memory location you can call it as a elements of the array. Okay, so the total number of elements you can call it to be the length. Okay, so the details are actually accessed about its position. Okay, so this one you can call it as the index or maybe subscript. Okay. So this is the concept of the arrays, okay, like A, B, C, D, okay. Like you will be having indices 0, 1, 2, 3, okay. And this is the, elements are being added, okay, at the position 2, okay. So the array length of the array is actually 1, 2, 3, 4. First index will be starting from only 0, not with 1, only with 0, and last index will be 3. Okay. So array is nothing but a container of elements, and elements will be having like specific value, okay, data type like maybe ABC, true or maybe false. So every element will be having its own index which is going to access the element, okay, and elements will be storing at the contiguous memory locations. And here the index is actually lesser than the total number of items. For example, if it is 4 means index will be totally 3 only, 0, 1, 2, 3. Okay, so that's the thing. And in terms of syntax, any variable that is declared as an array can be storing like multiple values, and almost all the languages will be having like comprehension of arrays, but definitely different ways of declaring and initializing. Then you have iterations, okay, so that's how the object can iterate over elements. So iterator represents a certain position in a container, and generally you can navigate from element to element. So iterator is nothing but pure abstraction. Generally you can iterate, you can add, okay, increment and so on. Okay, so iterator generally you will be having like a star, okay, that's nothing but a dereferencing iterator that's going to return the element at the current position. And then operator plus plus, okay, that is going to move the iterator to the next element. Okay, so most iterators also define minus minus also, that is going to move it to the previous element. Okay, then you have equal to and then not equal to. So equal to means same, like it's going to represent the same position. Equal to, that is going to assign an iterator, and you are going to set the position of the element that you are going to refer to. So iterator behavior is just like pointers. So iterators you can work much more easier with complicated data structures as well. And of course the real behavior, of course implementation depends on the data structure which you are going to iterate. Okay, so all the container classes will be having like same basic methods that you can use the iterators to navigate over the elements. So normally it will start like begin and then end. Okay, so begin means it's going to return the iterator that is going to refer the element at the beginning of the container. Okay, and then end means it's the end of the container, it's going to position to the last element in the container. Okay, so beginning means beginning element, last means last element. So this is the beginning, okay, and this is the end. So before that last element. Okay. So here the iterators are actually categorized, okay, based on the abilities. So everyone, okay, will be having standard library, okay, STL, okay, that is going to provide, okay, the iterators that belong to each of the following 3 categories. So here you will be having forward iterators, okay, bidirectional iterators, and random access iterators. Forward iterators means that is going to have the basic capabilities, abilities in the beginning of the section. So iterators, you can call it as a forward iterators, that the beginning of the section. Okay, so the iterators will be having the classes of unordered set, unordered multiset, unordered map, okay, unordered multi-map. So that's forward. Okay, bidirectional means both forward and backward. Okay, forward iterators and backward iterators. So here you will be having the classes list, set, multiset, map, and multi-map. So everything bidirectional. Okay, then you have random access iterators. So Same like bidirectional only, but in addition, it will be performing a random access. Okay, so you can actually add and of course subtract the offsets. You can compute the distance between the two random access iterators, and you are going to compare it using the relational operators. Okay, so less than or maybe greater than. Okay, so maybe iterators or maybe of vector, DQ, array, string, you can call it to be random access iterators. Okay. So there are other categories of iterators as well. Here you'll be having input iterators. Okay, so that you'll be having the read-only access while iterating forward. Okay, so iterators, this is the input iterators. Okay, so it's read-only. Output iterators means you're going to have write-only. Okay, write-only access while iterating forward. So output iterators, this is the example. And then you'll be having iterator functions as well. For example, advance, next and previous, distance, iterator swap. Okay, so advance means it's going to increment the portion of the iterator that is going to pass as an argument. Okay, next and previous means it's going to return before or maybe after. Okay, so after means next, previous means before. Okay. Distance, that's going to have the difference between the two iterators. Okay, and iterator swap. Okay, so that's going to swap the values to which the two iterators refer to. So next you will have invariance. Okay, so invariance is going to restrict the valid elements of the type. Okay, so dependent types can actually have like invariance as well, and of course only valid elements are actually well typed. Okay, then you have loop invariant. That's nothing but a condition that's going to go around the loop. Okay, that is going to have true immediately before and maybe immediately after the iteration of the loop. Okay, so a loop invariant is nothing but a predicate that is going to hold for every iteration of the loop. Okay, so maybe we will have this one int j equal to 9 for int I equal to 0, I less than 10, I plus plus. Then you have j minus minus, so that you are going to have true before and maybe after. Okay. So in this example, it is going to have true for the case I plus j equal to 9. Okay, so that is how it is going to compare. Okay, so a weaker invariant, that's also true, that's nothing but I greater than or equal to 0 and maybe I less than or equal to 10. Okay, so you need not have to confuse, okay, between the loop invariant and loop conditional statement as well. Okay, so loop invariant must be true before the loop starts or maybe before each of the iteration of the loop and after the loop terminates. Okay, so on the other hand, loop conditional, it should be false after the loop terminates, otherwise the loop will never ever terminate. So these are the loop invariants. Of course, it's going to capture the key facts, how the coding is going to work and why the coding will work. Okay, so which means that if you have to write the code in which the loop invariant is not obvious, you have to add a comment. Okay, that gives the loop invariant. So generally, the programmer also will try to understand how the code will act it to, and generally you can save from accidentally breaking the invariant with the future changes. Okay, so loop invariant definitely you can help in the design of the iterative algorithms. You can consider assertion characteristic as well and how you try to establish the relationships, okay, among holding the variables. So maybe if this is holding to be true, then the computation definitely it will be effective. Okay, if it is false means algorithm has failed. Okay, so loop invariants generally are the best way to understand the effectiveness of a given computer program. So maybe the trial and error also you can actually track the particular algorithms, and even when the complexity of the problem or maybe program changes, okay, or maybe increases, generally you can have loop invariants. That's how you can include the formal method of increasing the efficiency. Okay, so loop invariants you can provide or maybe prove the correctness of an algorithm. Okay, you can debug, you can actually find the error of the existing algorithm without even tracing the particular code or maybe developing the algorithm directly from the specification. Okay, so a good loop invariant, you will be having initialization which should be true before the first execution of the loop. Then you'll have maintenance, which means that if the invariant is true before the iteration of the loop, it should be true also after the iteration. So that is the. Then you have termination. So when the loop is terminated, okay, the invariant should tell something useful. You can understand that particular algorithm. Okay. So loop invariant is nothing but a condition, especially about the relationship between the variables of the program, which is definitely true, immediately before and maybe immediately after the iteration of the loop. Okay. For example, you have the array 7, 5, 3, 10, 2, 6. So totally we have 6 elements. Okay, we have to find the maximum element max in the array. Okay, so maybe you'll have max infinite, okay, minus infinite, okay, for I equal to 0 to n minus 1. If a of I is greater than max, then max is equal to a of I. Okay, so this one, after the third iteration of the loop, maximum value is actually 7. Okay, which is going to hold true, okay, for the first 3 elements of the array. Okay, so here the loop invariant condition is that the max is always the maximum elements, okay, of the array. Okay, so maybe in this example 7, 5, 3, 10, 2, 6, every element will go. Okay, so here 10 is the maximum element of the array. So this is the independent work for you. Binary search tree, BST. Okay, time complexity of insertion and search, priority queue, heap trees, basic operations in the binary heap tree. So this one we're going to research on this particular topic. Okay, this is very important in the higher levels. If you go into, even in the third year, you will go into definitely. People, in the even in the companies also, they will ask you questions. What is a heap? What is a queue? What is a stack? Okay, what is a binary search tree? Write a program for binary search tree. They will ask. Definitely you will be able to, you should be able to write even. So when you are able to write, definitely you can learn much more in the coding of data science.